Hello class, welcome to another online lecture for general chemistry, and today's topic is going to be a lesson with naming compounds. So there's several types of compounds that follow different rules when we're trying to name them, and those include ionic compounds and covalent compounds. Now I'm going to mention there's also special rules for naming acids. They have their own method when you're naming acids, but we're going to cover that in a different video because that gets into a little more detail just for the acids. So today's video, we're going to talk about ionic compounds versus what's called molecular compounds, which involve covalent bonds. So let's go ahead and get started with the review for today. So if you saw my previous lecture on forming ions and creating chemical compounds or chemical formulas, you should know that there are two major types of bonding that we look at in general chemistry, and that is ionic bonding and covalent bonding. So as a quick refresher, an ionic bond involves a complete transfer of electrons from one atom to another, while the covalent bond or covalent bonding is a sharing of electrons that are going to form a bond. So you get the two atoms together, they're going to share the electrons between the bond. The easiest way to identify an ionic compound is that an ionic compound involves a metal and a nonmetal that are bonded together, while a covalent compound or a molecular compound is typically going to involve two or more nonmetals that are bonded together. So let's begin the discussion by looking at ionic compounds, and then we will take a look at the molecular compounds after. So let's look at ionic first. When naming an ionic compound, we always want to list the cation first. Now remember, cation is a positive charge, and this would be with the metal. So remember that metals form cations. So when we're naming an ionic compound, we will always list the metal or the cation first when we're naming. The metal is going to be assigned its elemental name. So, for instance, if I use calcium and then I have some other anion with it, the beginning of the name is just going to be calcium. I'm not going to change it or add prefixes or suffixes. Okay? When we name the anion, which is going to be the nonmetal, we list that element second, and then we alter the suffix of its name to include an IDE, which we pronounce "ide." So let's take a look at some examples of binary compounds. And binary means it's made up of only two types of atoms. So there may be more than two atoms present, but there's only two types, two elements that are involved. So here are some binary ionic compounds. So the first one we see here is NaCl, and NaCl is named sodium chloride. So notice that sodium maintains its name, while chlorine ends up dropping the ene and becomes ide. So sodium chloride, we're adding that IDE. The next one we have is aluminum oxide. Again, the metal maintains its original name, aluminum, and the oxygen becomes oxide. So we're dropping the gin part and we're adding the ide to the ox. So aluminum oxide. Finally, we have here magnesium nitride. Okay, so one more time, we see the process here. The metal maintains its name as magnesium, and then the nitrogen is going to be changed to nitride. So that should be simple enough. That's the main way that you name an ionic compound. Now there's one other thing we want to discuss. So another important part to naming ionic compounds is that many of the transition elements, when we're talking about transition metals in particular, can take on a variety of charged states, and we call these oxidation states. When we list these transition metals in a name, we include the charged oxidation value in parentheses next to the metal name. So maybe you guys have seen this sometimes when you're reading a chemical name. In parentheses, you see some Roman numerals. Those Roman numerals are referring to the charge that would be associated with that ion, because a lot of these transition metals can occupy or take on more than one charge. So it might be a +2, a +3, etc. So take a look at the example that I have here, okay? Both of these compounds are iron oxide, and that's rust. So, however, one is iron 2 oxide, while the other is iron 3 oxide. And you can tell the difference based on their formulas. So if you have some trouble with this, you may want to revisit the lesson on forming compounds from ions and just review the lesson on predicting ion charges itself, okay? But again, with the transition metals, we need to include the charge in the number parentheses. So if more than one charge is available, in the case of iron, I can have iron 2 plus or iron 3 plus. I'm going to need to identify which one is being used, and I put that in parentheses next to the name of the metal. So that takes care of ionic compounds. That should be pretty simplistic. The transition metals, you need the parentheses with the oxidation number. And outside of that, if you're in one of the group A elements and not the transition metals, it's just the name of the metal. Okay, nothing too complex. So now let's shift focus over to molecular compounds. And molecular compounds involve the use of covalent bonds. While molecular units can sometimes be binary, like the example that we had when we were looking at the ionic compounds, they can also form more complex structures that involve multiple atoms. So for instance, glucose is C6H12O6. You have carbon, hydrogen, and oxygen. So for this lesson, we're primarily going to focus on binary compounds. So when naming a molecular compound, the first element written is going to just have the name of the first element. So in other words, it's similar to the ionic, where I just name the metal. So when I name the molecular compound, the first element that's written is just going to be the name of the first element. Okay? So it'll maintain its proper name, similar to the metals in ionic bonding. The second element will also follow the same process. You're going to change the suffix to "ide." So when we have chlorine, it becomes chloride, just like we had in the sodium chloride example. But here's where the main difference comes in. The main difference here is that prefixes are added to the first and second element to reflect the amount of atoms that that element is contributing to the compound. Now, there is one exception to this, and it does come up quite a bit, okay? The one exception to this is when the first element, just the first one, only contributes one atom, the mono prefix is dropped and just the element name is used. So if I'm looking at a molecular compound and the first element, there's only one atom of the first element, I do not need to include, or I should not include, mono in that prefix. It's just an implied that you have that one element. But for the second element, if I only have one of the second, it's going to have the mono prefix. Okay, so an example of this, and I'm going to show this in a second, if you look at carbon monoxide, there's one carbon and one oxygen. I don't call it monocarbon monoxide, I call it carbon monoxide, okay, or monooxide. And so when I'm looking at that, the oxide gets the mono, but the carbon does not. So just keep that in mind. But if, for instance, there's more than one carbon in the compound, it could be one of the other prefixes. So I might have dicarbon, tricarbon, tetracarbon, etc., as I'm counting up those prefixes. So that's the one rule that we want to consider. So here are some examples of these molecular compounds. And let's take a look at these. So I just mentioned carbon monoxide. The one right under that is a close cousin to carbon monoxide, carbon dioxide. So again, one carbon is just carbon, dioxide because I have two oxygens. Below that is sulfur dioxide. A lot of the sulfur gases have that nasty rotten egg smell. If you look past that, the SO3, I have sulfur trioxide. Then I have nitrogen dioxide. And then finally, here's an example where I have more than one of the first element. Dinitrogen tetraoxide, right? 2 nitrogens and 4 oxygens. So that would be the way that I name that one. So again, the prefix mono can be omitted from the first element. That's the one sort of exception to this rule. But if the first element has more than one, then you're going to make sure that you add that prefix. And so I will run through the prefixes here just briefly. And this is going to be in ascending order from 1 to 10. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca are going to be the 10 that you would most commonly use. Okay? And those are also important ones to learn because a lot of those are going to carry over to organic chemistry at some point when you're naming compounds in organic chemistry. So that pretty much covers molecular and ionic naming. The other thing I'm going to mention, we did mention the acids. There are also more complex anions. So they call them polyatomic anions. And that will have its own list. I'm going to put the list up here for a second. So it's right there. These are ions that you are going to have to get used to or memorize. There's no easy way around it. Okay, so the elements you tend to know their names, but some of these sulfate, sulfite, nitrate, phosphate, these are all important, and you're going to need to know that these complex polyatomic anions come as one group. We don't split them apart. But you'll get practice with that as you go along. Okay, so I'm going to put up some practice here. I'm going to pause the video and see if you can name these compounds, and I will put up the answers in just a second. So go ahead and pause the video now. Okay, so hopefully these are the answers that you got. I have them up on the screen here. If you're having issues with this, go back and rewatch this video again. Watch some of the previous videos if you need help in terms of coming up with compounds or formulating compounds. And other than that, this concludes this video. So please feel free to comment if you have any questions, or if you found that the video helped you, you can certainly like the video. Please remember to subscribe if you want the most recent updates whenever I upload things to my YouTube channel. And other than that, thanks for watching, guys, and I'll see you for the next lesson.